All right, last day, counting principles. How many possibilities are there? So the fundamental counting principle, which we talked about, an item can be used more than once, and the number of possibilities is m times n. So let's talk about that. And I've made reference to this before. So we're making a password. So we have 1, 2, 3, 4, 5, 6, 7, 8. I call this the dash method. You put the dashes there for the possibilities. There's 8 parts of the password. It says the first digit must be a number. Well, that's 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it says the next 7 digits must be a letter. Well, that's 26, 26, and so forth. Now, notice it didn't say anything about repeating. This means that the letters can repeat. If they didn't repeat, then it would be 26, 25, 24, and so forth. But since it doesn't give us a requirement, we just multiply straight across all these numbers in the calculator. Now, a quick way to do this, think about it. You have your calculator out, is just to do 26 to the 7th power, because it's 26 times 26 7 times. And then just tack on a 0 times 10. So that's 80,318,000,000, that's an extra 1, 101,760 different 8-digit codes. It's a lot. All right, we have a new math symbol. It's called a factorial. It's the exclamation point. What it means is 5 times 4 times 3 times 2 times 1. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, you can literally do that. 5 times 4 times 3 times 2 times 1 and get your answer. There's also a way on these calculators to use the stats keys. So if we hit the number 5 and then hit our math button, see PRB, that means probability. So if we go up there and see number 4, exclamation point, just hit enter. And we'll practice this in class. So for the next one, 8, instead of typing 8 times 7 times 6, we just type 8, math key, PRB, 4, 4, 0, 3, 2, 0, 40,320. Now, 5 factorial, we just said is 120. 2 factorial is just 2 times 1. Boom, 60. Now, new vocabulary, something called permutation. No item is used more than once and order matters. Okay? And this is the fancy formula form. I'm going to show you a calculator shortcut. So there are 10 prizes. 10 people in a track race. The first 3 get medals. First, second, and third place. So this is a permutation with 10 people and 3 valued places. Watch this. If we just hit 10 and then hit math and go over to probability, see that NPR? Permutation. 3, 720. There's 720 different ways 10 people could finish first, second, or third. Now, what's the math on this? Well, technically you do 10 factorial, and then you do 10 minus 3 factorial. So that's 10 factorial divided by 7 factorial. So if you did that, and did 10 math, 4, okay, and divided by 7 math, 4, you get 720. Okay? Now, combination is where order does not matter. So it looks almost the same, but notice you have this extra little r here. So this time we have 7, and we still have 3. But it's a combination because the order doesn't matter. The committee is just 3 people with equal votes. Now, if it was a president, vice president, and a secretary, that would be a permutation. But since there's no ranking, no importance, just equal standing, it's simply 7, math, PRB, and then number 3, NCR. Let me put the 3 in there. 35. Now, let's see what would happen if it mattered. What if the order mattered? There was ranking, president, vice president, secretary. So we would go to NPR 3, 210. So a lot more combinations if the order mattered. But here we're just picking 3 people. All right. Determine that the following are fundamental counting principle, permutations, or combinations. So order matters. Does not. Okay? So 4-digit numerical passcodes. Well, order definitely matters because 1, 2, 3, 4 is different than 3, 4, 1, 2. How many different ways a 2-person committee can be selected? Notice, just 2-person committee, no ranking, no senior partner, junior partner. Combination. 4 bands are performing on the program. How many different ways can they be arranged? Notice how there's only 1 number? That's factorial. 4, 3, 2, 1. 24 different ways. 20 old games in the bin. The sign says pick any 4 for 5. How many different groups of 4 are possible? Does the order you pick them or play them even matter? No, it does not matter. There are 5 questions on a multiple choice quiz, and each of the questions has 4 possible answers. How many different ways could you answer the quiz? Okay? And so here, order does not matter. Okay? You can answer the question in any order you want. That's it.